Hi everyone, thanks for joining us here for another TinkerPop Contributorcast. Just get the slides in here if we can. So today we're going to be talking about the recent releases of TinkerPop 367 and 372, which are the recent set of minor releases that have just come out. Thanks Ken, Valentin, and Yang for joining me today. So just go over the plan for today here. We'll give an overview of all the new changes that have gone into the new releases, and then because these are more minor maintenance releases, there's not a ton to get into there. We're also going to give a sneak peek at some of the new features coming for TinkerPop 4. So to get started, Yang, do you want to go over some of the initial bug fixes and improvements that have gone into 3.6 and 3.7?
Yeah, for sure. Thanks, Cole. So just a couple of the notable bug fixes and improvements. We actually had a couple of fixes that actually we observed like a very good, high performance improvements for certain query patterns. So first one, the top two actually are contributed by Stegma. We've seen a couple contribution from him. So the first one is the improved performance of the filter ranking strategy, where by avoiding expensive hash computation for these complex steps that contains nested traversals and many children. So with this change, it can be much more efficient. And as well, he also contributed the improvement to the bulk set contains check for elements. And as well, we have another performance improvements related to the path retraction strategy. So with all these performance improvements, we've actually observed up to like 50 to 60 times faster in the query compilation and execution time for these specific query patterns, especially involving complex queries. And as well, one big bug fixes actually involves the mid-traversal usage steps of the merge E and merge V operations. So this fix actually prevents some potential data corruptions, because it was observed that these, when used in mid-traversals, the merge E and merge V may actually operate on incoming. They operate on incoming traversers in certain cases. So yeah, and then back to you, Cole. That's something you've helped.
So one of the other things that I wanted to highlight here today is we've now got a multi-architecture Docker image for Gremlin console. So previously we've supported both x86 and ARM for the Gremlin server image. That's now been rolled out to Gremlin console as well. So for all you ARM users, now have a working Gremlin console image natively. So that's super exciting. Some other maintenance stuff we've got here is Gremlin Go has now been bumped to minimum of Go 121. It's just following the Go end of life cycle. So this Go 120 is aged out. We're now using Go 121. And in a similar note for 3.6, we've now moved Gremlin JavaScript and Gremlin to Node 18. 3.7 has already been on Node 18, but Node 16 has reached end of life. So now everything's standardized on Node 18 for us. And one more change I want to highlight here. This is contributed by Tian, who is a recent new contributor for TinkerPop. There's a bug with the SASL authentication where if you ever had multiple requests coming in while the handshake was still in progress, the request would fail with authentication failure. So this bug's now been fixed by Tian. Tian's stepped in with a few big PRs actually the last few months, which has been really great to see. Another one that came in that's not in this release is Tian added TypeScript support, which is merged into master. So that's going to be in the next major release. So super awesome work from Tian. Hope you stick around here. Hope to see a lot more from you. It's been really great. And yeah, that's about it for the big things in 3.6 and 3.7. So we'll get into some of the new stuff in TinkerPop 4 here. So starting with the biggest thing is adoption of HTTP 1.1 as a standard protocol. So Ken, could you let us know a bit more of what's going on there?
Sure, yeah. I guess if you've been following the sort of devless posts, the idea here is that, yeah, we're just trying to standardize in the next major release, so TinkerPop 4, on one transport protocol. So we're going to move forward with HTTP 1.1 at this time, which means we're essentially getting rid of support for WebSockets. WebSocket support will stay in 3.7. So, and 3.7 is probably going to be maintained for a while yet. So I think the idea there is if you want to use WebSockets, you continue on 3.7. And if you want to use the new HTTP stuff, you move to 4. That means that we have HTTP technically in the server in like 3.6, 3.7, but this new one will operate differently than how that old sort of HTTP server worked. They won't be interoperable.
All right. What sort of changes can users expect as they switch from WebSockets to HTTP with this upgrade?
An end user. So I'm thinking of it as an end user, not a provider, because sometimes when we talk about users, like providers and end users, so like an end user of Gremlin, like a person who just wants to send Gremlin to the server. If they're using the GLVs, I think ideally they should see little to no change. Since it's just a swapping of the sort of backend sort of like transfer protocol, which we don't sort of show to the user anyways in the GLVs. But however, because we're moving from obviously WebSockets, like you can have multiple requests through one connection. You don't really do that in HTTP 1.1, and we don't support pipelining. You're going to have some configuration differences in the GLVs just because of like some of the options that made sense for WebSockets just won't make sense for HTTP 1.1.
All right, cool. So sort of simplifying things a little bit, make it a bit more stable. Sounds good. Valent, another thing that's coming in here is there's the removal of bytecode. It standardized on Gremlin scripts. Could you shed some more light on that?
Yes, now we need to support 2 ways of execution script, and same script can be valid for bytecode execution, but not for Gremlin or vice versa. To reduce amount of support and to have single standard, we consider to support only Gremlin script in TinkerPop 4 and remove bytecode execution.
Yeah. Can I just jump back into
Sure.
the HTTP 1.1? You know, like we've had a couple of discussions out there too. Just gonna circle back to it. I think Ken gave us a great overview. I think there had been some PRs, and we see that there's a branch called Master HTTP that's out there. I think folks can actually check that out, and then if they want to take a look and start on that. But Ken, do you have any comments, elaboration on that, like on what's currently actually out there?
So if you're asking about the Master HTTP branch in particular, what we sort of several weeks ago I posted in the dev list about like what we want the request response to sort of look like. In Master HTTP, that's pretty much done. If you pulled the Gremlin server image from that branch, or if you built it, and not pulling the image, so we didn't build the image, but if you cloned that branch, or you check out that branch and then you build the server from it, you'll have the request that it expects. It's going to expect in that form, that new form. That new form being that we got rid of the processors, and so we've sort of flattened all of the fields in the request, and the response. There's some metadata things that we removed from the response, so of that sort of request response the new sort of format of those, the master HTTP branch already contains that in the server. We don't have any working drivers right now, working GLVs in master HTTP. So you sort of need your own HTTP client or tool, something like curl, to sort of issue requests against it. But yeah, that's the current state of master HTTP, if that's what you're wondering.
Cool. Thank you.
Cool. It looks like we've got a question in the chat as well here.
Nice.
Just pull that up. So yeah, how is authentication parameters sent now in WebSocket protocol, and how will it be done after changing it to HTTP 1.1? Ken, are you able to take that one?
Sure. So another thing we discussed is that we're getting rid of the SASL mechanism for a bit. We sort of discussed it, and we said that in the dev list post, it's sort of open right now as to whether or not we bring SASL back in when we move to HTTP 2. However, so right now in HTTP 1.1, the plan is just going to be basic auth. So it's just going to be using the authorization header, that sort of base 64 encoded username and password. That's the sort of auth we're going to support for now.
All right. Yeah, we've also got another question here on transactions. Yeah, so are we planning to enable transaction support after moving to HTTP? Valentin, do you want to jump in on that?
Yes, we definitely plan to support transactions, but we still don't have concrete plans how we will do this.
So the other thing about transactions is like planning to enable after moving to. So the way transactions is sort of works right now via sessions is not the way we want to do it moving forward. Like Valentin said, that there's still ongoing discussions on the dev list about how transactions should work, but I think everyone in the community agrees that yes, we will definitely need to have transactions, but it won't look like how it used to look, if that makes any sense.
And we do welcome inputs from the community if you have any thoughts or concerns or comments regarding how the transaction is now and how, what type of transaction support you would like to see. It's also feel free to jump into the existing discussed thread. Feel free to open your own or, drop notes down in the Discord.
Right, got another one here. Are there any benefits using HTTP 2 or even Quick? Ken, I know you've done some thinking to HTTP 2.
Quick probably isn't useful for us because of how we use our transport protocol. We don't really have those we don't issue a bunch of small sort of like, oh, get this sort of thing. So that portion of it isn't that useful for us. HTTP 2, on the other hand, yes, the big thing about HTTP 2 would be that you can issue multiple requests on the same connection. So HTTP 2 streams. And then that would, the nice thing about HTTP 2 is that it moves us back to more like how we had things in WebSockets, I guess. I don't know if that's nice, but I mean, like, it's more similar, the concepts at least. But yes, that would be the main benefit of moving to HTTP 2 for us would be right now when we move to HTTP 1.1, one of the issues is if you're going to if you want to have like, I don't know, for some reason you have like these bursty workloads where you're going to issue like thousands of really small Gremlin queries at once. What's going to happen right now with HTTP 1.1 is we're going to have to suddenly open like 1,000 connections, and that's going to have overhead. That will sort of be taken care of when we move to HTTP 2. So that's, from my perspective, I think that's the largest benefit.
And do we have any more questions? Just gonna
everything in the chat right now.
Yeah. Okay. I guess I was just wondering about like we talk about the server. What about what's in the brewing for the GLVs? Like we have the master HTTP with the servers. Ken was saying that like a quick dev preview version, but do we have any connectivity yet? Just think.
So the current state of HTTP, like you can, so the driver, the Java driver, so Gremlin driver, that package, it kind of works right now. So what happened was, since we're moving so how it used to work in 3.6 and 3.7 is that the request ID was sort of sent by the client to the server, and then the server would use that request ID, and in WebSockets at least, what it would do is it passed that request ID back in each of the returning WebSocket frames, and that's how the GLVs knew like sort of which result to map that sort of that frame coming back from the server to. So when we moved to HTTP 1.1 initially, we had kept that same design where the client would issue the request ID. But since recently, in the last, like, I think 2 weeks or something like that, when I posted that message to the dev list about how we would do the HTTP API, we've changed it so that the client doesn't issue the request IDs anymore. And so that's sort of, so what happened was the driver was kind of working, and then it stopped working after we made that change in the server. So right now we don't have any fully functional drivers in master HTTP, if that's what you're wondering.
Cool. Thanks, Ken.
Yeah, so we got one more question here, I believe. Just trying to find it here. Yeah, there. Yeah, is there much performance difference between WebSockets and HTTP when it comes to usage by the GLVs?
So that is actually the major difference between the TinkerPop 4 HTTP implementation and the HTTP implementation in 3.6 and 3.7 right now, is that a huge amount of the effort went to making sure that latency-wise and in most throughput cases, that the performance will be very, very similar. So the reason in 3.6 and 3.7, the HTTP's implementation on the server side is quite slow versus WebSockets is that it always took this. It only took script queries. So in mostly Gremlin Groovy, but probably sometimes Gremlin 9 as well. And then what it would do is it would run the entire thing first, the entire traversal in memory, then package that traversal up, and then send that back. So you get, which is not how the WebSocket request works, because in the WebSocket request, the traversals run in batches of whatever result iteration batch size is, and then it gets streamed back to the drivers. There was a lot of work in TinkerPop 4 to make sure that the HTTP protocol worked the same way as how WebSockets works, to make sure that the request is also streamed back. So since we're using HTTP 1.1, we're using the chunk transfer mechanism to do it. But yeah, that's there to ensure that the performance can be relatively similar. Valentin's actually the one that worked on a lot of making. So to make that work, we had to make the serializer stateful in order to be able to serialize and deserialize in these random chunks coming back from the server, because you're getting just one large response now. How it worked in WebSockets before was like the message was broken up into lots and lots of small response messages. Not how it works in HTTP 1.1, but so we changed the serializers to make them sort of streamable, and they keep state now. I don't know, Valentin, if you want to talk a little more about the effort that went into making that work.
It's one of ways to increase performance for our HTTP implementation. So for WebSockets, we send full response message in each WebSocket frame. So lots of information are duplicated, which is not needed for our HTTP implementation. So to add streaming, we introduced new graph binary v4 and graphzone v4 with streaming support. So now we can split our response message into chunks and send one by one. And GLVs can consume it also one by one, not waiting for entire result, how it works in previous HTTP implementation in 3.7. So streaming support is main feature in new serializers. Most likely we will drop support for previous ones because they don't support streaming.
All right. I think unless there's any other questions, I think that covers all the topics we wanted to introduce for TinkerPop 4. So going back to the full scope of the presentation here, if you need a comprehensive list of all the changes that have gone into the recent releases, be sure to check out our changelog here. So that's got the complete list of all the work that's gone in. Once again, thanks to all the contributors that have stepped up and contributed some awesome work here. One piece I want to add to this as well is if you want to stay up to date with all the work going on in HTTP and TinkerPop 4, just stay tuned to the dev list, keep an eye out on the repo for some PRs, and yeah, make sure to stay engaged and let us know what you think of the direction we're going in. Give everyone one last chance for some questions here. Yeah. All right. Doesn't look like anything's coming in. So yeah, thanks everybody for joining us today. Hope to see you on dev list, see you in Discord, and I'll see you again after the next release. All right. Thanks everyone.
See you.